Hi folks, hopefully by now you know the routine. This is your Professor Dr. Mink, and as I've already mentioned at least 2 times, that's not me. So make sure you have your volume up, and if you have any questions, just pause this and contact me and I'll get right back to you. Enjoy the lecture.
This is just another friendly reminder that you should be reading the textbook before reviewing the slides for the particular chapter we're covering or section of chapter we're covering. This is ultra critical in an online course. I'm not saying this because I want to give you a hard time or give you busy work. It's because I know how important this is in a class where you and I are not physically present together, and you have the ability to ask questions and I have the ability to look at you and see a puzzled look on your face and say, hey, what don't you understand? Let's explain it. So in an online course, you have extra responsibility for self-directed learning. And please, for you and for me, read the chapter before you review this particular lecture. So you should have read all of Chapter 2 before you got here and already started to formulate questions about concepts you're not sure about, review the lecture, and the slides in the lecture might solidify the concepts I'm trying to present. And then after that, if you still don't understand, you could Google the questions you have, or you could send questions to me via the forum or email them to me. Okay, sorry about that. I'll tone it down moving forward, but this is an important part of the process, okay? Let's get started with part 2 of chapter 2. This slide begins the material from section 2.4 in your textbook. This is a fun topic for me to cover. Simple flow of control. We'll talk about how control is executed, the sequence of execution within a program, and we'll also introduce the concept of a branch. So just hold on, we'll get to that in 1 second. Flow of control means simply the order in which program statements are executed. And it's not always linear. In other words, if you have a program you've written that has 75 lines, that doesn't mean that line 1 will be executed first, 2 second, 3 third, 4th fifth, or 4th, line 4 4th, oh jeez, tongue-tied at number 4. I'm not going to go line by line to 75, but you get the meaning of what I'm trying to say. I hope you do. If not, raise your hand. I'm sorry. Nobody's here. A branch lets the program choose between 2 alternatives. And we'll have a condition, and if a condition is true, we'll branch, or the flow of control will go in one direction, and if it's false, the flow of control will go in another direction. This is where we really start to get into the logic of programming. It's a very, very powerful programming construct, the branch. This slide presents pseudocode or an algorithm for a branch, and it uses a very, very common scenario, the calculation of hourly wages, how much a person gets paid in a given work week. And in most environments, if you're paid by the hour, let's just say $20 per hour, it'd be a pretty good rate for a college student. Your regular pay for the first 40 hours you work is called regular time. And the expression used to calculate your gross pay for that week is the rate times the number of hours you've worked. And you use that expression if the number of hours worked is equal to 40 or less than or equal to 40. However, if the number of hours worked is greater than 40, let's say the person worked 50 hours in a given week, well, you have to branch to a different different expression. Gross pay then becomes rate times 40 for the first 40 hours. That's your regular time rate, plus 1.5 times rate times the number of hours worked minus 40. So if a person worked 50 hours, the first 40 would be paid at regular time, and the last 10 hours minus 40, hours would be 50, minus 40 would be 10 hours, would be paid at time and a half. The program uses a branch to choose which of these expressions to use, and that branch would be determined by the number of hours worked. Less than or equal to 40, true, do this. Greater than 40, false, do this. To design the branch, you need a condition which, when evaluated, returns true or false. So, decide if hours is greater than 40 is true. If it is true, then you use the gross pay equals the rate times 40 plus 1.5 times the rate times hours minus 40. That's the equation that calculates gross pay if the individual works over 40 hours. If it's not true, then use the equation gross pay equals rate times hours. The direction the branch takes is based totally on the results of the condition, true or false. Here we have the actual implementation of the branch in C++. We use, in C++, an if-else statement. This is the actual code that you would put in a program to calculate the gross pay based upon the rate and the number of hours worked. You put an if, and then the condition, hours greater than 40. Notice no semicolon. If that's true, it will execute the statement or statements immediately below it. If it were more than one statement to be executed, we'd put brackets around them. So if hours greater than 40 is true, say the hours was 50, such as the example I mentioned in the slide before this, then gross pay is calculated with using that formula, the overtime formula. If hours greater than 40 is false, it skips over the true expression and it goes to the else, and it calculates gross pay simply as rate times the number of hours. Let's say the individual worked 30 hours. Well, there's no reason to use the whole gross pay, the overtime rate, because the condition was false. On this slide, we have a fully implemented program that uses the if-else statement we detailed in the previous slide. It has the setF statements to control the output of, double variable, gross pay, and rate. And it uses an integer to hold the number of hours. And I strongly suggest you take this code, download it from WebStudy. I'll put all the code in the timeline, and load this code into a compiler and run it and enter different values so you get an idea of how the if-else statement works. Looks like the first dialog, sample dialog 1, 30 hours is going to use, that's going to use the else statement, gross pay equals rate times hours, because hours greater than 40 will be false. And it looks like the second one uses the if statement, the first statement that is executed if this is true. This slide shows the formal syntax for an if-else statement. The first example is a single statement for each alternative. So you've got if, and then you've got a Boolean expression, an expression that can either be evaluated as true or false. That's it. So hours greater than 40, well, that's either going to be true or false, depending upon the value of hours. Then you've got the yes statement, the statement that's executed if it's true, and then you've got the no statement, the statement that's executed if it's false. Now, you can also have a sequence of statements for each alternative. Same syntax, if Boolean expression, and then you have an open bracket, and you can have 5, 6, 100 things that are executed, 100 different statements, 10 different statements, multiple statements that are executed, and then you just close that with the bracket, and all of that will be executed if the Boolean expression is evaluated as true. And you can do the same thing with the else or the false statements. If the Boolean expression is evaluated as false, it skips down to the statements after the else, and it will execute with the brackets all of them. Very, very useful programming construct. We will use this extensively throughout this class. So this is not something you should move forward with if you're not 100% crystal clear on this, because it will trip you up moving forward. I'll gladly help you with it during, if this is a hybrid class, come see me during the class sessions. If this is an online class, you're going to have to come see me during my office hours or post questions for me, and I'll try to answer them. We'll get together, but don't move forward without fully understanding the if-else statement. Boolean expressions are very important in conditional situations. And Boolean expressions are expressions that evaluate out to either true or false and no other state. We use comparison operators such as greater than to compare variables and or numbers. The Boolean expression hours greater than 40, hours being a variable, I'm assuming it's an integer variable. So if when that expression, that Boolean expression is evaluated, if the value in hours is greater than 40, then that expression is true. So if hours equals 40 or less, that expression is false. 41 or greater, it's true. There are no other options. Some other symbols or comparison operators that are used are greater than or equal to, not equal to, which is the inequality symbol, and equivalent to or equal to. This slide lists the most common comparison operators. Equal to, the math symbol equal to is two equal signs next to each other, or equivalency. And there's an example of how it would be used in an expression. Not equal to, exclamation point equal to symbol, less than or equal to, greater than or equal to. And examples of C++ Boolean expressions are listed in the fourth column on this slide. A Boolean expression is required in the if-else flow of control. And here's how if-else works. If, and then in the parentheses, is a Boolean expression. If that's evaluated as true, the true statements are executed. If it's evaluated as false, it skips over to the statements after else. Else flow of control, where there are multiple statements to be executed when the Boolean expression is evaluated as true, and multiple statements to be executed when it is false. This is a branch. If the Boolean expression is true, it branches to the true statements. If it is false, it branches to the false statements after the else. And notice the brackets. If you want more than one statement to be executed when it's true, you have to put those statements in brackets. The AND operator allows you to combine multiple Boolean expressions. In other words, if this is true and this is true, do this, else do this. When you combine Boolean expressions with the AND operator, all of them must be true in order to execute the true statements. If one is false, the entire expression is false. So if I say, if today is Sunday and today is a day in January and the date is an even number, well, if any one of those is false, the whole thing is false. The OR allows you to combine multiple Boolean expressions for the branch, and the difference between OR and is, with OR, if any of the conditions are true, the entire condition is true. So if I say, if it's Sunday and it's a day in January, well, if it's Sunday in February, the whole thing is true. Or if it's Saturday in January, the whole thing is true, because either or needs to be met. Only one condition needs to be met. Not negates a Boolean expression. In other words, if the Boolean expression being evaluated is true, such as if x is less than y is true, if you put the exclamation point, the not, outside of that, if it was true, if x is less than y, it makes the entire Boolean expression false. And if it was false, it makes it true. So it flips the switch, if you will. Example of a situation you need to be careful with, and that is translating inequalities to C++. If x less than y less than z translates as if x less than y, double ampersand, which is the and, y less than z, not the straight translation if x less than y less than z. One of the most common mistakes I see in students who are learning C++ is to mistake the assignment operator for the equality operator. The assignment operator is used to assign a value to a variable. So, for example, if we want to assign the value 3 to x, the example is x equals 3. The double equal sign is the equality operator. This is used in expressions to compare values and to evaluate them as true or false. So, for example, if x is equivalent to 3, if the value of x is currently 3, that returns true. If the value currently in x is not 3, that returns false. However, the compiler accepts the error of using the assignment operator in an expression instead of the equality operator. But it stores 3. It changes the value of x to 3. And since the result is 3, which is a non-zero, the expression being evaluated is true. So be careful with this. This slide presents a very important concept, which is compound statements. A compound statement is more than one statement enclosed in the brackets. Many branches of if-else statements often require execution of more than one statement. In other words, if the expression being evaluated is true, you might have 3, 4, 5, 6 statements to be executed. Those statements need to be within brackets. So here's an example. If the Boolean expression, and then the statements that get executed if the Boolean expression evaluates to true are in brackets if there is more than one statement to be executed. And that also goes for the else or false statements. If there's more than one statement or line of code to be executed, you must put them in brackets. This is display 2.10, an example of a compound statement used with if-else logic. The condition being evaluated, the expression being evaluated is if my score greater than your score. So two variables, my score, your score. Let's just assume they're ints for the sake of this conversation. I can do that because I'm in charge here. If my score is greater than your score, execute the cout statement, I win, new line, and the assignment statement, wager plus 100, gets assigned to wager. So wager gets increased by 100. If my score is not greater than your score, in other words, the expression is evaluated as false, it skips to the else statements and executes the compound statement, including the cout, and wager goes to 0. This is a very simple but good example of compound statements, very, very common with if-else logic. This concludes the section on branches, and the author gives 2 small projects you should be able to complete in order to demonstrate your competence with the material presented in this class. Can you write an if-else statement that outputs the word high if the value of the variable score is greater than 100, and low if the value of score is at most 100? The variables are integers. If this were a traditional class, which I am teaching this semester, when I got to this slide, I'd have students, we would write it together. I'd have students diagram this, and it's not that difficult. So you should try this at home. If you have problems and you're in an online class or a hybrid class, contact me. Second one, write an if-else statement that outputs the word warning, provided that either the values of the variable temperature is greater than or equal to 100, or the value of the variable pressure is greater than or equal to 200, or both. Otherwise, the if-else statement outputs the word OK. So you're going to have an and in your, or in your condition, your expression being evaluated. Loops are a very important programming construct. I've not seen a programming language yet that did not have a method for loops. Loops are used when an action must be repeated. A loop is typically an iterative process. C++ includes several ways to create loops. The first one we'll start with is the while loop. And here's an example. While the variable countdown is greater than 0, okay, so while that is true, that expression is true, execute cout hello. And, well, obviously we've got a compound statement here because we have brackets. Cout hello, and then countdown minus equals 1. Remember, that's a shortcut that translates to countdown equals countdown minus 1. So if countdown starts at 10, we go into the loop, we output cout hello, countdown gets decremented to 9. We go back up to the top of the while loop. Is 9 greater than 0? True. Go into the loop again, cout hello. So the example here at the bottom of the slide outputs hello, hello, hello when the value of countdown is 3 at the beginning of the loop. It'll be 3, go into the loop, it gets decremented to 2, goes into the loop again, gets decremented to 1, goes into the loop again, gets decremented to 0. That becomes false, and it just skips over the compound statements because it only executes the compound statements cout and the countdown minus equal 1 when countdown greater than 0 is evaluated as true. This slide shows an implementation of the while loop we discussed previously. In the main program, we declare an int countdown variable. Then we prompt the user with the cout statement, how many greetings do you want? Through cin, we accept the user's input from the keyboard to initialize the value of countdown. And then we go into the while loop with the expression being evaluated, countdown greater than 0. When that is true, the while loop will continue to loop. So obviously, look at the sample dialog number 1. If we type in a 3 as the initial value, the loop will loop 3 times. If we type in 1, it'll loop once. If we type in 0, it will loop exactly 0 times. So it won't loop. And then after the number of loops, it drops out when the expression countdown greater than 0 is evaluated as false. So when countdown gets decremented by 1 each time through the loop, it eventually goes to 0, and the loop drops out. And then we go to the cout endl statement, which just simply puts a new line, and then cout, that's all. This slide details the operation of the while loop. First, the expression, the Boolean expression, is evaluated. Remember, a Boolean expression can only be evaluated as false or true. If it's false, the program skips to the line following the while loop. It's real simple. If it's true, the body of the loop is executed, and during execution, some item from the Boolean expression must be changed. That was the decrementer, changing the count to count minus 1, lowering the count by 1, because something has to change in the body in order for the loop to eventually end. After executing the loop body, the Boolean expression is checked again, repeating the process until the expression becomes false. If you're not changing something from the Boolean expression and it goes into it as true, it will never enter. So never stop looping. It will be an infinite loop. A while loop, it's also good to note that a while loop may never execute if the Boolean expression is false on the first time it's evaluated. This slide details the syntax of the while loop. While the Boolean expression is true, in brackets, the statements to repeat. And those statements must include a change to something in the Boolean expression so that the loop will not be infinite. Semicolons are used only to end the statements within the loop. This is display 2.12 from the text. It has some good reminders here. First, you have an example of a while loop, or the syntax of a while loop with several statements. While, Boolean expression. One of the mistakes I see students make often when they're first starting to program while loops is they put a semicolon after the Boolean expression. You do not put a semicolon after the Boolean expression. Semicolons only go at the end of program statements. So in this first example, you have a loop body with several statements, and they are enclosed in brackets. And then in the second example, you have a while loop that only has a single statement, only one statement to be executed. That's the body. So you don't need to have brackets. Another loop, which is a variation of the while loop, is called the do-while loop. A do-while loop is always executed at least once because the condition, the Boolean expression, is not evaluated until after the body of the loop is executed. So the body is executed first, and then the Boolean expression is checked after the body has been executed. You use this variation of the while loop, the do while loop, when you need the body of the loop to be always executed at least one time. Here we have the syntax of the do while loop. First we'll look at a do while loop with several statements. You start with do. Notice there is no Boolean expression at the beginning of the loop, because that is the primary characteristics of do while loop. The Boolean expression is checked after the body. So do, and then you have the statements enclosed in brackets, while. Here's an example of a do while loop. In the main program, we declare a char variable ans. We drop down into a do loop. We see out hello and a new line. Then we prompt the user with a cout statement. Do you want another greeting? Press Y for yes, N for no, and then press return. And then using cin, we accept the input from the user. Then there's the while statement, and there's the Boolean expression being evaluated. While answer is equivalent to lowercase y, or ans is equivalent to uppercase Y, you continue to loop. So as long as this person types a Y, lowercase or uppercase y, they will get another iteration of the loop. How many times will this loop execute? Well, the minimum will be 1. You will get 1 hello regardless of whether or not the user types in yes or no, because the body of the loop, which includes the cout statement hello, gets executed before the Boolean expression gets evaluated. This is an important difference for you to note between the do while and the while loop. If you're going to talk about loops, you've got to discuss increment and decrement. Increment means to increase the value, and decrement means to decrease the value, to lower the value. Unary operators require only one operand. Plus in front of a number such as 5, plus 5 means it's positive, minus 5. The increment operator, plus plus, which is how C++ got its name. The increment operator adds 1 to the value of a variable, and it's kind of a shorthand notation. So if you have the statement x plus plus, semicolon, that's equivalent or shorthand to x equals x plus 1. The decrement operator subtracts 1 from the value of a variable, so x minus minus, semicolon, is equivalent or shorthand for x equals x minus 1. These are very, very, very useful operators. We're going to use them over and over and over and over again. When you have a loop, you must have a decrement, or, well, you almost always have a decrement or increment operator. Let's take a look at a sample program that uses a loop and an increment operator. Here are the parameters of the program. A bank charge card balance of $50, 2% interest charged every month. You want to know how many months without payments before your balance exceeds $100. So some sample calculations. After 1 month, you've got $50 plus 2% of $50. 2% of 50 is $1. So you got $51 balance. After 2 months, 2% of your balance, $51, $52.02. After 3 months, this is an excellent example of a situation that would be easily programmed using a loop. And we'll take a look at the actual code in a second. The problem described on the previous slide is easily solved or implemented using a while loop. What was the condition that we're going to be evaluating? While balance is less than $100. So let's start at the beginning. We set a double variable called balance and initialize it as $50. That was the initial amount, or balance, if you will. And then we set a counter, an int called count, and we set it to 0. And then cout statement, this program tells you how long it takes to accumulate a debt of $100, starting with an initial balance of $50 owed. The interest rate is 2% per month. We go right into the while statement. While a balance is less than $100, well, balance starts at 50, so we're good. We drop down into the loop body. Balance equals balance plus 2% times balance. If you remember, the first month, 2% of 50 was $1, so the balance becomes 50 plus $1 or $51. And then count gets incremented by 1. So that's after the first month, then the second month, third month, and the balance continues to increase each month, and the months are kept track of by the counter. Ultimately, the value of balance will equal or exceed $100, and the expression being evaluated while balance less than $100 will return a false. We will simply drop down, we will skip the body of the loop when that becomes false after having looped many, many, many times. And then we will use a cout statement after, notice the space in the quotes, count months. So we're keeping count of how many months it took for the expression to become false. And we use our setf statements to designate fixed point notation to show the decimal point and 2 decimal places to the right of the decimal point. Don't worry about those. We'll see them 100 times. I'm not going to ask you to memorize them. And then cout, your balance due will be, and then the balance. There's a sample dialog, and it tells you that after 36 months, your balance will finally exceed $100. It'll be $101.99. So I'm assuming after 35 months, the balance was still below $100. I've given you this code in the timeline web study. I strongly suggest you pull it down, put it in the compiler, play around with it. You could change the value of balance and see how this works. Aha! Here we are, infinite loops. Infinite loops can cause a problem. They never stop. The loop body must contain, or should contain, a line that will eventually cause the Boolean expression to become false. Here's an example. Print the odd numbers less than 12. So we start with x equals 1, and then the expression being evaluated is, well, x does not equal 12. Execute the body of the loop. And we cout x end line, and then we increment x by 2. X equals x plus 2. So the first time we go through, we output a 1. X gets 2 added to it, so x becomes 3. We go back in, x does not equal 12. We cout a 3. Then it becomes 5. We cout a 5. Then it becomes 7. We cout a 7. Then it becomes 9. You get the idea. We're outputting odd numbers because we started with an odd number and we're adding 2. 9, 11, 13. Uh-oh. Well, we still do not equal 12. We skipped over 12. This concludes section 2.4. Some little simple exercises for you. Can you show the output of this code if x is of type int? You should be able to write that code. If you can't, let me know. I will help you. Can you show the output of the previous code using the comparison x less than 0 instead of x greater than 0? Sure you could. The last section in Chapter 2 discusses program style. There's not a lot of content here, but it is important. You do want your program to look professional, which roughly translates to not sloppy and easy to follow, well organized. Let's take a look. A program that is written with attention to style is easier to read and understand. It's easier to correct or debug. And it's easier to make changes to. I'll tell a very quick story. In the 1980s, yes, I'm a middle-aged, borderline old man. I was a programmer, Fortune 500 company. Company's name was Boeing. They built aircraft. You probably have heard of them. Many of you have probably flown on one or more of their planes. I left there over 20 years ago, and somewhere around 2005, I got a call from a friend of mine who stayed and is still a programmer there, and I had been gone about 15 years. His name was Lee, and he said he had to modify a program that I had written in 1987. He saw my name in the documentation of the program, and he realized we hadn't talked in a while, and he thought he looked me up. He sent me an email to college, and now there were no problems. I said, well, are you calling because there was a problem with a program I wrote 15 years ago? He said, no, just seeing your name, and the program's fine. I fixed it, or changed it. The requirements changed, and we made a modification. But just so you understand, if you become a programmer, the programs you write could have a longer life with the organization than you do. And someone, one of your colleagues, or maybe someone who is hired after you leave the company for a better job, different opportunity, retirement, whatever, could have to go in and make a change, a modification, because the requirements changed. They may have to change a program you wrote years ago. And if it's not easy to read, it's not well documented, it's sloppy, it doesn't have style, that will be a direct reflection on your abilities. And those individuals will draw conclusions about you. Positive if you've done a good job with program style and documentation, and negative. And if you're anything like me, your reputation is important to you. So this is a somewhat important issue. Let's take a further look. With regard to program style, indentation is a good idea. It's a very good practice, and items considered a group should look like a group. So skip lines between logical groups of statements and indent statements within statements. So for example, the if loop, the if branch. If x is equivalent to 0, and then the statement to be executed should be indented because it is part of that if. Braces can be used to create groups and indent within braces to make the group clear. If you've got a compound statement, multiple statements to be executed, indent them. Put the braces and then indent all of the statements which are part of that group. Braces which are placed on separate lines are easier to locate. Remember, C++ is not all that concerned with skipped lines and spaces, etc., etc., etc. It's only to make the program look better, easier to understand, easier to change, etc. Comments are a critical part of a well-developed program. 2 front slashes is the symbol for a single line comment. Comments are explanatory notes for the programmer. They do not get executed by the compiler. All text on the line following the double slashes, front slash, they're ignored by the compiler. So here's an example. Comment, calculate regular wages, and then the next line is the calculation for regular wages. That makes it so much easier for someone else, or for you coming back to a program that you stepped away from, to find. If you want to enclose multiple line comments, you start with a front slash asterisk, and you end with an asterisk front slash. So here's an example of a multi-line comment, a comment that spans multiple lines without the comment symbol on the middle lines. This slide begins a discussion of constants. Number constants have no mnemonic value. They can't be changed. Number constants used throughout a program are difficult to find and change when needed. However, constants allow us to name number constants so that they have meaning, allow us to change all occurrences simply by changing the value of the constant. And more on this in the next slide. You're probably thinking, what the heck is he talking about? Hold on. Const, C-O-N-S-T, is the keyword to declare a constant. Typical protocol is to, when you have a constant variable, a variable that can't be changed within the program, you declare it as all capital letters. So it makes it easier to find. Once again, its value cannot be changed by the program. It is common to name constants with all capital letters. And you'll see examples of why you need a constant variable later in this class. Here's an example of a program that uses a variable named normal. It's a double, but it's set as a constant. Why? Well, it is the normal temperature in Fahrenheit degrees for a human being. And that is 98.6. Obviously, you would not want the program to change that because the normal temperature is always the normal. So it's declared as a constant double, and its name is in all caps, Normal. Take a look at this and you'll see why you would use a constant for normal. That, my friends, concludes section 2.5. It also concludes chapter 2. Some suggested exercises or questions from the author. Can you create a named constant of type double? We just did that on the previous slide with normal. Can you determine if a program can modify the value of a constant? Sure you can. Can you describe the benefits of comments? Sure you can. Comments are used as documentation to help the programmer or someone who is going to change the program later to find and read the program more intuitively. Can you explain why indenting is important in a program? It's a critical component of style, and it keeps sections of information together. Blank lines are important to separate major program sections. Thanks for staying with me, and this concludes chapter 2. Next we'll go on to chapter 3. Have a great day.